Okay, hello and welcome to Virtual Coffee Lunch and Learn Edition. Virtual Coffee's mission is to be a welcoming tech community that allows room for growth and mentorship at all levels and to create meaningful opportunities for learning, leadership, and contribution for everyone. To find our code of conduct, events, and learn more, you can check out our site at virtualcoffee.io. Really glad to have all of you here with us today, and especially want to thank our presenter for being here, Mark Noonan. Mark is a senior engineer at Cypress.io. Cypress is this is not Mark's bio anymore. This is me talking, but Cypress is a really great tool. I use it a lot. It's awesome. He works as a program developer for People Making Progress, an Atlanta-based nonprofit serving adults with developmental disabilities at home, work, and in the community. Mark was on the podcast, I don't remember when, but talked a lot about that experience and working with nonprofits and things like that. So if you'd like to learn more about that, obviously feel free to ask Mark, but also check out the podcast episode because I think it was a very good one. And you can follow Mark on Twitter at Mark T. Noonan. So without any further ado, I will pass it off to Mark.
All right. Thanks, Dan.
Yeah.
And hello, everybody. Let me share my screen here. So yeah, thanks for coming to this Testing Sea Monster talk. This is my first time giving this talk, so some of you know a little bit about it already, but yeah, it's great to have a chance to try it out and see how it goes. Dan covered everything in my first slide, except RefCode, refcode.org. That's a nonprofit that teaches like programming education, like early career skills to refugees and immigrants in the Atlanta area. So that's a really good thing to check out. You can volunteer online as well as in person. So I believe there's a new cohort starting in a few weeks that's going to go through a 10-week web development program. So if you're interested in supporting that, you can check it out there. So that's me on the left, just a dude telling a story. And in this presentation, you are this junior crew member. You're on the SS front-end development and you're setting sail to deliver yet another quality feature on time and under budget. And we're just going to kind of go through the story here, and the story is going to lead us to certain testing concepts, and then we're going to step out of it and talk about them and jump back in. So yeah, super interested in feedback after this about what's good or bad about this format. So let's just get into it, and then we can talk later about that. So your ship sets forth and the crew starts work, building up some basic components and helper functions required for the feature that you're delivering, along with some low-level tests to confirm all the pieces are working. That's the starting point of our building. So we'll jump out for a second and talk about unit tests versus component tests. It's pretty natural when you're getting started building something and you have just a little bit of work to do, like let's make the buttons, let's do kind of component-driven development. We'll make the buttons and things that we need. We'll make the pieces that are going to be used by bigger pieces. And likewise, we might have some business logic that is, a function in JavaScript that's going to start to do something important that's related to the requirements we have for this feature. So we're starting to put the pieces together, and we think a pretty good idea is to write these low-level tests. The way I think about unit testing is to think about it as like really testing a single unit of business logic, so a plain JavaScript function. Some people would say it should always be that, but to me, it's okay if you have a function that happens to import other stuff and like also uses that stuff. It still can be considered a unit test if like its functionality is like an encapsulated conceptual unit in your code. So we'll take a quick look at an example of a unit test. But basically the structure is you're going to call a function and assert the return value of the function under various conditions. If you pass it different arguments, is it supposed to behave differently? And you write code that executes it and then looks at the result and passes or fails based on the result. Unit tests are great if you're writing a plain JavaScript function because they run really fast as you work on it. So if you come back the next day and you're going to extend it with a new piece of functionality, you can use all the tests you wrote yesterday. They'll just really snappily rerun and confirm if you accidentally broke something else in the function as you were modifying it. Even though we might look at a unit test running in Cypress, you do not need a browser to run a JavaScript unit test. Shouldn't run a unit test in a browser. So here's one to look at, right? We have a simple function here. It's called add, and it's going to take two numbers and put them together, return a plus b. Unless one of the numbers is less than 0, and then it's going to complain. And we can have a test that describes this behavior. And we're using the syntax here with describe and it to like identify the parts of our test. So describe the add function, and this it block is going to be a single test within this overall spec. So this add.sci.ts is called a spec file or specification of the behavior of the component that we want to test, or in this case, the function. So we can say, assign a variable called results, right? Assign the outcome of this calling this function that we've imported from right here. And we expect that to be 5. If I want to add 1 and 4, we'll expect that to be 5. And I can come over and we can see this test actually running. So in Cypress, we can run this same kind of JavaScript test, right? Cypress is just doing JavaScript in the browser. So we might talk a little bit more about how this tool works, but it's running in the browser, so we can spin it up and execute this just to see the results. And we can see we expect 5 to be 5 and 14 to be 14. And that corresponds to these two assertions here. Expect result to equal 5, and then do it again and expect it to equal 14. The benefit this gives us is if we were to change this function to, let's do subtraction instead of addition or something like that, we'll immediately have something that fails and tell us, oh, you made a typo, you put the wrong thing in there. So this gives us some comfort that this function is doing what it's told. And it's also telling us, like when you come back later to look at this, it's a way to understand, especially through these it blocks, what is it supposed to do? So if we take away this only here and we take a look at the other tests, we're going to be able to see, oh, it's supposed to actually do something different, right? This is refusing some behavior. So down here, we expect the result to be this message, not the actual math, because we've changed the arguments. So that's the core of like a very simple example of how a unit test works. And then on the other side of that, on the UI side, we have a front-end component test. This is where you can mount a component in isolation, you can run its render function, and then you can sort of behave as a user in your test context. So instead of just saying, oh, I expect this entity in JavaScript, right? This variable is supposed to be something here. In our component test, we're going to say, I want to look at some piece of my application and talk about how does it work? How do users interact with it? And does it do what we expect? It's the same spirit though, right? As a unit test, it's sort of the unit test of UI, especially in that we're able to set it up, perform some actions, and make an assertion about what happened, and document what we expect the component to do. Component tests can execute in a browser in certain frameworks like Cypress and Playwright, and component tests also kind of more the state of the art is that component tests will execute in node-based environments where you execute the function that renders the component and you test stuff based on like a simulated DOM. And so there's a trade-off between the speed of doing that, which is certainly faster, and the confidence of actually using a real browser rendering engine, CSS from the browser and stuff like that. The main thing, the last point here is please don't test internals in component tests. That would be my main thing. If you have business logic that you want to test that belongs to your component, you can extract it and you can write a regular old unit test for you. You don't have to do that in the component test itself. And there's some other considerations we'll talk about later about whether you even need to extract the logic, depending on how your component test works. So let's take a look at a couple of simple component tests here. This one is failing. This is a button test that expects the button to contain this text here. Click me, KJ, KJ. So obviously this test is broken, it's deliberately failing. But we can see the same pattern here, right? Whereas before we imported a JavaScript function, here we import a component. Instead of calling the JavaScript function, we mount the component. And after mounting, we expect, okay, we didn't pass in arguments, but we used a default slot to put some stuff in here. And we've got an assertion about what the output contains. In this case, we don't have to assign it to a variable like result and think about that. What we can do is just say that it should be in the DOM, because this web page here is really our result of mounting our component. So if we inspect this here, we can see just all the stuff that's going on is right there for us because it's the real component in the browser. And I can come and delete this extra text here. And now this is passing we're able to say, okay, cool. This component is doing what we expect. It's receiving this in its slot, and it's creating this text inside of a button element, and that's all that we want. So all the other component specs here work in a similar way. We won't look at them all, but you can see they start to test bigger and bigger things, right? The input field has some more behavior. The login form has multiple input fields and is doing user actions, and those are all happening. Take a quick look at this. These are all happening through asserting about what's in the DOM, and at a certain point, typing things into it, clicking things, and expecting some side effects in JavaScript, right? This is a login that's supposed to emit an event that does logins or call a helper function to handle it. So we're mixing like the assertions about JavaScript and assertions about the user-facing stuff. And that's totally fine because components have developer-facing behavior and user-facing behavior. So you get going, and as soon as you reach international waters, there's a rumbling from below and a giant sea monster appears. So you're perfectly happy with your unit test and your component test, and you're feeling confident about what you're doing. But the sea monster says, unit tests don't prevent bugs. Haven't you seen the meme with the sink? And he's waving around this photograph for you, which I'll make it bigger here. There it is. This is popular meme about unit tests surpassing. Okay, the sink pours out water, that's fine. And the faucet pours water and the sink catches water, that's all okay. But clearly something is a bit wrong here. You couldn't fill the sink up, for example. And arguably, this is kind of an integration test as much as a couple of unit tests, but this is a popular way to almost dismiss unit testing and say, well, it doesn't tell you that the system is working and that things are the way you want them. So the captain says, let's go home. Testing is pointless and software was a mistake. As the crew turns the ship around, you start visibly shuffling charts in the hopes of looking busy and not being asked to do anything. All of a sudden, a sheet falls out that shows the path to end-to-end testing. What if we go here, you say? It says we can still deliver the feature with confidence if we go this way. By Jove, I think she's got it, says the captain. Turn the ship around, head for end-to-end testing. Very volatile captain. So now we'll talk about end-to-end tests. In reference to component tests that we just talked about, let's go back and talk about component tests first with a view towards how they're different to end-to-end tests. So we talked about them one way, comparing them to other unit tests, but we also can talk about them as being like vertical. So now we've accepted there's a component rendering in the browser and we're inspecting, like we said, it should be a button and it should have this type of text. We're able to check all the elements the component renders. We're really deeply checking this entire kind of part of the component tree. It is user-facing, but it's also developer-facing. Like we saw briefly a login spy that was like an event handler that was being called. So that's part of the component API. You want to test that if you are going to use that component other places so that when you work on this one component, you know if you broke it for other consumers of it. And the other thing about component tests is usually you're going to have that test open just like a unit test when you work on that component. So you get really early feedback about something failing. On the other hand, an end-to-end test will visit a running website or an app. They tend to be more horizontal in my mind than vertical. So we're checking user journeys across pages that might pass through many different components. Stuff like, can you add items to your cart? Can you check out? Can you have a correct tax calculation based on the things that you did? Or use contact forms, like important business things that cut across the website you really want to know. These are often just going through the UI, so we don't have any interaction or knowledge of the code or the framework underlying the front end. And so-called true end-to-end test would not have any part of the system stubbed. You would have a live server or live front end and just do exactly what a user would do to really validate that the whole application is working together. Because of this, they tend to run in CI, and sometimes different teams will be making end-to-end tests compared to component tests, so they may even be maintained in a separate place. And for that reason, they run a little bit less often locally. So you certainly can run an end-to-end test locally while you're working. And that can be useful if you know for sure that end-to-end test cuts through the feature you're doing. But it's usually pretty slow if you were to want to run all of your end-to-end tests every time you save a file locally to just make sure that you didn't break something somewhere. Usually you push your code up, CI can run them, and they can run as fast as possible up there, but still take a little while to get you your results. So let's take a look at an end-to-end test. We'll switch Cypress over to end-to-end mode. And here's one just to visit that demo app that we talked about. So there's, a website running here. This is the app that we have that's like just here for the demo. All it does is log in. And I don't know if that was the right password, but that's fine. So it has some state because you're logging in and you're giving some error feedback, and you can also see what it looks like when we really do log in. We type, yeah, it's just test password, what do you know? We click and we get this welcome screen. And then there's a little bit of a Star Wars thing that we'll come back to later. But this end-to-end test is different from the component test in that we go to this localhost whatever, which means your website has to be built and running there in order to write the end-to-end test. Other than that, though, all the same stuff we saw about like, oh, click a button, check if it's got the right text, all that stuff works exactly the same in your end-to-end test. Okay, so a short while after entering the clear waters of end-to-end testing, the ship is seized again by the tentacles of the sea monster. End-to-end tests are complicated, slow, and prone to flakiness, booms the sea monster. You'll never deliver this feature. You'll have to wait for the API team to finish before you can even start. Let's get out while we still can, says the captain. Delivering quality software is too hard. Again, you bury your head in the pile of charts, and this time you emerge with a little area of the ocean off to the sides of end-to-end testing. Captain, you say, it says here that if we make a left up ahead, we can stub the network and get out ahead of the API team, and then just meet up with them at the end right before delivery. They'll go here and we'll go here. Parallel. Parallel. Sounds like a bulletproof way to increase velocity with no downsides, says the captain. Hard to port. So we'll talk about network stubbing. Network stubbing is where you write code that will pretend to be a server for your test purposes. So as far as your application is concerned while it's being tested, it's reaching out to ask a network for some request, and we're doing something in our testing world to reply with simulated data as though that server was actually receiving the call. But the important thing is we're intercepting it before it reaches the server. There are a couple of ways to do this. The one we'll look at is called side.intercept, but this principle applies no matter how you like to mock your server. So to summarize it, we avoid hitting a live backend. The front end will see the network activity just the same though. Whatever we specified in the test, it will still be in the network tab and look like the regular network activity. It works in component and end-to-end tests the same. You can stub the network if a component's supposed to reach out and call an API. You can handle that in a component test. It really helps with front-end handling of edge cases. So if you have a server that's supposed to return like a 500 or a 404 or other error codes, that it's like hard for you to make it do that in a front-end test where you just want to make sure the UI is able to handle the error from the server, you can intercept that request, never let it get to the server, and just reply with the bad status code so that your UI has to handle that. And in your test, you can make sure that state's correctly handled. So stubbing the network has some benefits. It speeds up the text execution because you're never waiting for the network to come back with information from a server that the server had to process and respond with. And it can reduce flake for the same reason, because you're never going to have a test that times out when it's trying to reach something on the server and the server's maybe restarting or whatever. On the right-hand side, you can see what intercept looks like. We'll take a quick look at an example next, but essentially you would say specify, okay, when the front end requests /some API /1, instead of going to the API, just reply with this object. So this is a very minimal way to say, okay, well, pretend that it gave back this object. Obviously, for longer things, you want to handle it differently. But the principle is we're just going to make it look like this is what came back. So we have a test open that's already using this, which is in this visit demo app test. So the state after you log in is showing this Luke stuff. So if we do this, test password, that was right. I don't know what's going on there. That's okay though. If we look at this behavior here, we have actually, let's take away this for a second. So this is grabbing a fixture, which is a simpler way, right? We're still passing it in here. Let's take a look at this fixture first. Luke Skywalker. So this is an object. It's just JSON giving some information about Luke Skywalker. The reason it's Luke Skywalker is that we are actually hitting the Star Wars API, which if you don't know this is a way to get just information about people in the Star Wars universe and other Star Wars stuff. So in our code, we are hitting this API, and in our test, we're going to simulate hitting that API. So what I'll do is I'll take out, great, yeah. So I took out the request that was being simulated here. Now let's take a look at the network activity of what happens. So there was a loading state, then we got this, and there was this. We got back that information from the API. And if I had my fixture in here, it would look no different. The main thing that would be different is the loading state's probably a little faster, right? We didn't see as long of a loading state because we didn't really wait for it there. But we see the same thing came back. And if I modify my little fixture, and I'm just going to say, what if it was Han Skywalker? We'll rerun this test. And we can see that this time, that's what came back from the data. And this time in our network tab, that's what came back. So to the front end, it's exactly the same, whether we're using the fixture data or not. So we can definitely use this feature not only to simulate the actual API as it is now, but if we know that API changes are coming that would change the shape of these objects, and we want to write components that are going to implement features using new things in the API, we can use this to say, oh, actually, we should have like a awesomeness feature in here. And if we had that, we can say that's what should be in there. Run our test again. Our test is passing. But if we come down, we can see, oh, we got that extra thing. So now we're able to start working with future API features before they're even deployed. So that lets us move quickly. It also helps us control the variables when our tests are actually running. So we can address the sea monster's concerns of like tests being slow and prone to flakiness by stubbing the network a lot. We don't want to stub it always, but we can stub it quite a lot, as much as we need to get all those variations if we want to actually test responses to strange things that are coming back from the server. And also we can use it to just make tests a little bit faster if we are already covering something once with the live server. We maybe don't need to always do it in every test all the time. So anyway, it wasn't long after entering the sea of network stubbing that the sea monster arose once more. Ha ha ha, now that you've mocked the API layer and don't need to run the API to test, how will you know when the API has changed and make sure your code still works? But the captain had been this way before. You can't fool me. I know this one. Give me those charts. If we can make it here, the captain pointed, we can use our mocked responses to test the real API and be alerted as soon as changes are deployed that would invalidate our mocks. And so the ship set sail for the cool and calm lagoon of API testing. So as you probably were feeling, if we looked at what happens when you mock the server, it's like, okay, it's not an end-to-end test anymore. So like we can be passing perfectly, right? We can get ahead of changes that are happening in the API, but we can also hold on to wrong data. If that API changed and our front end didn't know about that change and we didn't update our mocks, we could have passing tests, but they're passing based on what the old API was, and then you don't find out about a problem until you've pushed to production and your real front end starts using your real new API or something like that. So API testing is one possible solution to this. It has other purposes as well. But API testing is where you would make a request directly to an API. So instead of visiting a page, you would use sci.request or something similar in a different tool to hit an API endpoint, get the response back. And now you have a test written that can say, hey, when I call this API point or when I post data to this other place, I expect the server to respond in a certain way. And now we're not stubbing any of that. We're just saying, give me the real activity on the server when a certain payload is used. We completely skip the front end. Some apps don't even have a front end, right? They're just an API. And we can test the contract of the API. This is especially helpful if the API and the front end are in different repos. So the API is being tested by the team that builds it in a way like this. That gives them early feedback. If there's something that's changing, that's breaking the contract, that's really useful. And this kind of testing, again, does not need to be done in a browser. It doesn't require a browser to render anything on the page in order to perform this type of testing. So you can do it in a number of ways with a number of different tools. But some people do like to use a browser for it anyway, and that's the kind of test we're going to look at now. So this is using a package external like Cypress plugin that's going to test the API response from this Star Wars API. So we'll take a look at the spec first. In this way, we're not using that sci.request command that we just had in the slide. We're using Philip Rick's custom API command in Cypress because that's what produces this nice UI here. This is not built into Cypress. This is just the behavior of this plugin that we're using. But we get a result, and we can do one thing, right? We can wrap it with Cypress and we can explain, oh, it should have this particular behavior. And we can see, yeah, something's failing here. So let's take these one by one. Let's pause this. So at this point, we're okay. We've said, yeah, this should have Luke Skywalker. Great. And we also got this part. This is coming through. We expected this array to be 4. There's a very big difference between wrapping something in a Cypress command and just directly calling like a synchronous expect. It can sometimes lead to unexpected things, funnily enough. And in this case, you can see the array stuff, this assertion here, is happening before the stuff that's built into the Cypress command. So we won't get sidetracked by that, but there's reasons you may want to choose one or the other depending on the nature of your data. It shouldn't matter for API testing because there's not like a page underneath that's changing. But we did have this last one here, right? So for clarity, let's comment both of these out. And we're using that fixture again. And we're saying that, okay, the result.body of this should deep equal the person. Yeah, this person should deep equal the Luke Skywalker fixture that we had over here. And we changed this fixture to have this extra property. So it's failing now because our fixture like added in the awesomeness stuff, but that awesomeness stuff doesn't exist in the actual response from the API. So when we fix the fixture, get it matching again, the API test will start to pass. And having some link like this between a real deployed API and the fixtures that you're using in the front end so that we are able to know that, like, you wouldn't really just deeply compare the object. You do something more generic about, like, what's the schema of the object, what properties does it have, how should those values kind of look. But having this connection between your API level testing and the mocks being used in your front end actually feels to me like it gives a lot more confidence about the validity of those mocks over time, so that we don't end up getting too disconnected. We don't have mocks that change and then we accidentally release a front end that's using the awesomeness field that's not going to be there until the back end deploys again or something like that. So having all these things aligned is a really nice way to use testing types differently, but to support the same goal. So anyway, I'll still catch you somehow, cried the sea monster, waving its many tentacles. Still avoiding work, you aimlessly look through charts and logbooks until you realize something. Captain, you say, we're not going to make it. We're moving too slow and the monster will catch up to us here. You point to a spot on the map, days away from shore. What? How? We have so many tests. We're too heavy. We need to drop some tests to pick up enough speed to deliver on time. Well, what are the heaviest tests? They're the end-to-end ones, Captain. But they provide the most confidence. Yes, but also, according to this, they provide death at the bottom of the ocean. We have to let some go. Keep only the most important user flows. Can they log in? Can we get paid? And do the contact forms work? What about the others? Move those into component testing. Save what you can. Maybe without running the whole full stack banking application to test an accordion, we might move fast enough. And the network? Stub it in all the component tests, but then we really have to keep testing the API. And about those component tests, yes, cut anything that checks internal methods, but developers love testing the internal, throw them overboard. The developers, the tests. We're in a browser after all. And on this ship, said the captain with a new seriousness, we go through the user interface. So that's the kind of discussion you might have when you feel like you're over testing. Things are moving along and you have all kinds of tests. So all your bases are constantly covered and recovered and extra covered. And it can be tempting once you learn about testing to maximize your confidence by testing everything all the time. But that actually is sort of what makes people sometimes hate testing. It feels like we're doing the same thing in multiple ways over and over, and it's very redundant. And some of the ways that's handled is just by reducing testing altogether or leaning really heavily on one type of tests. We say, well, we don't need end-to-end tests because we have 100% code coverage through unit tests. Or we say we're just going to do end-to-end tests and we don't need component or unit tests because we're gathering information about the critical user flows. And those perspectives can be valid in certain situations, but they also end up costing you some of the nice parts of testing where it can help you in your development experience by having locally relevant tests that you can run on your machine while you work on a certain part of the code. So when I've been learning more about testing over time, I feel like I've been working on identifying what matters to test and then where it matters to run those tests. For your situation, nobody can tell you what your perfect balance is among the different types of tests. You can get extra confidence and really fast feedback from the unit, component, and API tests that are just targeting independent parts of the system. That gives you the freedom to develop those parts with knowing the contract they will have in the future with other parts of the system. You can develop those independently early. On the other hand, end-to-end tests give you slower feedback because they usually run in CI, but they ensure that users can accomplish critical tasks. And if you stub the network in your end-to-end test, you can increase speed and stability while reducing confidence a little bit. So you can balance these things. If you make heart monitors at the hospital, you probably have one testing profile that you need, and it's not a one-size-fits-all. If you make marketing landing pages, you probably have some other stuff that you might want to test heavily and some things that are not as important. Generally, if you run a business, if you had to only have one kind of test, it would be end-to-end tests for users who could, making sure they can give you money and that they can do things that are critical to your business. That's definitely the most important health check that you can have. But in order to have a nice life and quick feedback about changes you're making to understand what's happening, the lower level tests can be really useful for that, and they make it a lot easier to onboard new developers. So to avoid capsizing, I would say use testing types together, but carefully. This stacked approach that we're talking about here brings you all of the benefits, but it comes with that risk we just talked about of over testing. The other risk is things becoming messy and confusing. So the way I see this represented the most when I look at test code is that we sometimes have near duplication across unrelated tests. This is especially true if like all you have are end-to-end tests, because you can have testing that will, pass through many pages, and sometimes a test will assert, oh, by the way, while you're on this page, check these things. And a similar test that's going through the same page, but for a different purpose and ending a different user journey, that test might say, oh, check these things, make sure the title's correct, make sure the navigation item is active and stuff like that. And it becomes really hard to understand what is tested where. Like, where's all the true things about the navigation state collected, and where's all the true things about the footer collected, or something like that, where we're just kind of relying on end-to-end tests with similar but different things to coincidentally catch everything. To me, that like mixes the horizontal and the vertical aspects of testing, and it makes the end-to-end tests kind of bloated beyond the user journey they're focused on. So component testing for me is a good way to address this, because you can have the health check, you can have the user journey tests, but you can also have really precise, specific tests about the behavior of your component, and you know where to look for that for everything. If you have one component source file and one test that goes with that. And there's deeper things about component testing strategy to avoid repeating that duplication problem at the component level. But these are the things to kind of be aware of if you're just kind of getting into testing and thinking about how to do it. It's really easy for it to just seem overwhelming, and like there's all this contradictory advice and nobody knows what they're doing. I think that's still kind of true, because anybody even giving you advice is giving it from their background and their knowledge and their situation. You have your own needs. So I think the best step to like get a good relationship with testing is to understand what are the needs of you and your team, and what testing types are going to like serve you well. As the day of delivery draws near, the final destination is in sight, and the tentacles of the sea monster recede over the horizon. The crew sheds a collective sigh of relief at last. All except for one lookout in the crow's nest, scanning the empty seas in every direction with a telescope, looking for that ship they were supposed to meet. Now, how's that API team doing? The captain shouts up. So that is that. Thank you for listening to that. I'm happy to stop sharing and take questions. You do not have to fill out the Cypress feedback form that is just here, because it is the end of all of my slides.
Thank you so much, Mark. That was awesome. I really appreciated that. I said this at the beginning, but I love Cypress, and I enjoyed the different characters and stuff. We actually had a question. Somebody joined a little bit later and was trying to understand the significance of the different characters and stuff. But
sorry, Red.
Yeah, Red. It will be recorded. I mean, it is recorded. We'll put it up on.
Yeah.
Yeah, so if anybody has questions now, this would be a great time to ask them. You can put them in chat. You can raise your hand if you want to. If you feel like turning your camera on, feel free to do that. Raise your hand, or also obviously drop them in the chat.
I do see Kirk's observation here about analogies with typing here. Kirk, you're probably right, and I should put like TypeScript in here as like static types as being one of the kinds of testing, which is sort of down there in the testing trophy model as well.
Yeah, I think I agree with that. Well, speaking of Kirk has his hand raised, so Kirk, go ahead if you have another question.
First of all, that was a super cool talk. I really like that. That is probably
thanks, Kirk.
my favorite testing talk that I've ever listened to.
That's great. Thank you.
My question was, so I am really super interested in those like API mocking tests. And like one of the things you noted was that like it's going to come back faster because you're not actually hitting a real server. So like Cypress is handling it. Is there any way to like bake in a delay for that? Or like, I don't know if it's like a Cypress has to do it, or if you can just like wire something together to sort of see like, okay, not just the payload, like what does this look like when the network / server is slow to respond?
That's interesting. I think that there probably is, I don't know if it's like, if you consider it baked in, but I think that you can like, within intercept, what you pass as that second argument can be like a function that knows how to resolve the request. So you can do a timeout or whatever you need to do there to then like, yeah, you want to test your loading state. You can just say, what if this like never comes back? Or you can set it like, imagine your UI has handling for a request that it just takes too long. You could say, okay, well, I'm going to make this take 6 seconds to respond. And after 5 seconds, my UI is actually supposed to cancel the request and start again or something.
Thank you. That is exactly what I wanted to know. And that sounds great. And I just, Dan and I were just like, we have a million ideas. Thank you.
Oh, super cool.
Yeah, I was, you can do, and I'm like, you can do a ton with intercept, and obviously you don't want to get into every single little thing that you can do in a talk that's supposed to be under an hour. But yeah, there's tons of really, really cool stuff that you can do with intercept. Because I believe in, correct me if I'm wrong, Mark, you can, just like lots of other middleware setups, you can adjust the request. Like you could still send a server, you can use intercept, still send it to a server, but adjust the request to the server, which is cool. So you can send a special header saying, hey, we're in a Cypress test right now, do something or whatever.
Right. Yeah, totally. So like when you're done making this user, delete them or something like that.
Right.
Yeah.
It's cool. Yeah, Nick, go ahead.
I was just gonna say I had another interesting use case for the Intercept. Like when I worked at Dev2, we would have analytics go off and stuff, and sometimes it would cause, or there would just be like background things happening that weren't really related to the test. So I was able to just kind of use Intercept to just say, kind of like ignore this, which was kind of handy. And
like just like don't even go and get that thing, or
that, or just say like return a HTTP okay or something, instead of, because what would happen is that, because like when the tests start running really fast, because like in CI/CD, because it's not a human obviously, sometimes requests would not be able to complete for something that wasn't related to the test. So you could just kind of, the Intercept was kind of interesting for that, I found. So
yeah, that's cool.
just wanted to mention that.
All right, go ahead, Jennifer.
Sure, thanks. So as someone for whom this is really sort of my first view of testing since my boot camp, I have a lot more kind of entry-level questions. So didn't know what Cypress was before walking into it. So
that's good to know. Yeah, that might have needed more explanation. Go ahead. Yeah, sorry.
Yeah. And then I can't remember. I know I also have a question mark here on integration tests. So I don't know if you covered that later or not, but when you were talking about it just after unit tests and component tests, I was wondering what that was. I also really liked that you had a female character in there. Considering that tech is so very male heavy, nice having that diversity.
That's that's a female sea otter.
Yes. Let's see, what else? Horizontal versus vertical testing. I would like some more description on what that means. And then also I felt like I liked the story and how it kind of carried. It feels like I'm getting an understanding of how testing might work in an actual development environment. And so I appreciated that and sort of how it fits into the big picture. But I also felt like in some places with the story, like when the captain is actually, instead of saying, oh no, let's stop, is actually suggesting things to do, maybe some summary pages of sort of putting the story into best practices, or kind of explaining the solution that he found in the story, explaining what that actually means. So I'm not sure if the next slide really covered that, or I think, like I said,
Yeah.
a lot of this is so new to me that I'm going to have a lot of questions no matter what. But those are sort of the things that occurred to me, and I really like this. This has been enormously helpful, and even also just having like the login app is a nice little chunk that has some functionality and has interface, but it's contained. So it's, and the fact that you can use that little chunk and write all those different types of tests on it, so that, you know, that's something I could create and I could run through those testing scenarios and I could understand it from that standpoint as well. I really appreciate that.
Well, cool. Thank you so much for all the feedback. Yeah, I think that I have, because of the time that this took, I think I actually have a little bit more time in the talk than I thought to make the examples perhaps a little bit deeper, or go slower to be like, oh, hey, by the way, if you don't know what Cypress is, here's what it is. That would probably be a good idea, because there's not a presumption. Like, Cypress is just a tool that the talk uses. Most of the concepts don't require Cypress. It's just simpler to stick to one tool. Plus, I work at Cypress, so I really enjoy showing it off. Like, that's a nice thing for me. But explaining, yeah, this is a test runner. Like, what is, you know, how do tests run? Right, I got slightly into that with the describe and the it blocks. But it might make a little bit more sense to just do the anatomy of what's happening. And maybe the best way to do that would be to start with the component, not the unit test, so that you see the typical use case of Cypress first, and we can explain things, go into the browser, and then we can test them. I like your comment about horizontal versus vertical. I think I will explain that a bit more in the future. One thing that's not in this talk is like accessibility, which is the purpose of doing a test that a button has a certain text or something like that. So that's the really vertical stuff for me, where you drill into everything that your component does, compared to a test that is moving through the UI. And I also think you identified a stretch that felt like it was just too much of the story all at once for me, where it is that back and forth and we don't stop. And I'm not quite sure yet how to make that better, but you're right that, like, oh, he just dispatches these orders of like, we have to make these tough calls, and we don't get to think about those trade-offs with actual, like, what does that mean for what we already saw? So yeah, as I was saying it, I was feeling like that section, I thought I didn't have time to do that, but clearly I do. So that's good.
All right, thanks.
Thank you.
Yeah, go ahead, Nick, if your hand is still up.
Yeah.
Nice.
I was gonna say, if you wanted to get a little more theatrical, you could do a Wes Anderson themed. You've got all the nautical stuff going on. You could be suiting up in like Jacques Cousteau maybe for the talk.
It's a good idea. I'm going to do this talk at KCDC, and then later in the year at Magnolia JS, which is a Halloween themed conference. So there will be people in costumes. And I could see that. I also think at KCDC, some people have offered, like Meg mentioned, character voices. Some people have offered to like join the talk and do the voices, which I wasn't sure how I would feel trying to read it all like this. I am welcome to hear feedback on how that went, but I already feel like, oh, I would love to have some other people sharing the spotlight.
Yeah, no, that'd be super funny. And for the, you were saying about the trade-offs, you were kind of rushed there. Is that what you said before, or to explain it?
Oh, the part of the talk where the captain is like, okay, well, move this kind of testing into API tests, or move this, you know.
Okay.
It's like, yeah, that's a pretty quick back and forth. And it might be better, even if it's slower to tell that part of the story, it might be better to be like, this is why you would keep only these end-to-end tests. And this is why, like, when you have to cut weight, you would drop this kind of testing. What I think I missed in here is, like, you kind of end up forcing tests down to the lowest place where you're still happy to have them. So if you can get away with it in component testing, do that. It's a lighter weight form of testing. If you can get away with it in unit tests by extracting your business logic, and it's not
Yeah.
impacting the UI, do that. Yeah.
Yeah, I guess like and then I'll let Meg go. But you could kind of make the analogy of like the ship's not going to sink if you get rid of some tests, you know, like the ship will still sail, but maybe parts of it won't work as well. But it doesn't mean it's like, I don't know. Anyways.
But no, I understand what you mean. Yeah. We're like, we have to focus on, you can't just write all the tests that you want all the time. You don't have time for that.
Yeah. Cool. Great talk.
Thanks, Nick.
Go ahead, Meg.
I'm pretty sure, I don't know where you made the PowerPoint. It looked really good. First off,
I'm so glad. I purchased some clip art with money.
well, it looked great. I remember back in like the old days, you could actually put sound to the slides, and like the little speaker icon you click on. And so even if someone's not there with you, you could have like a recording of someone's voice. And I'm telling Narando to do the sea monster.
That's so good.
Great call.
Yeah, he would be perfect for that.
Yes.
So that's my contribution to this. But
That's a tremendous one.
it was very good, Mark.
Thanks. Did anybody find it just like too silly or like ridiculous or anything? It's kind of my concern that this would be like, just, I don't know, not content, right? Not educational content about the topic, but just like too silly.
Honestly, this would be a really good talk to be like the right after lunch talk, because normally people are like tired because they just ate, but this is like unique and different, and I think it would engage people and wake them up. So it's like different enough that people would be like, oh, what? A sea monster with a broken
Yeah.
sink?
Right. It's not the same as the same procession of facts that you get and that I
Yeah.
like to do as well, where it's just slides with facts and you show things.
It's a good
Yeah.
mix. It's a good mix of silly and info.
Oh, Yearn, slaying the sea monster. Looking in the chat there, that's an interesting talk that I should check out. You may have already told me about it actually, and I either did or didn't check it out.
Yeah, I'd also add, I mean, I think it's great. I don't think it's too silly at all. And I think I agree with everybody else. The only thing it needs is some more voices and stuff like that. I think it's okay to lean into it. I don't personally. And it's good that it's not like, I don't know, you're not talking like a pirate the whole time, you know what I mean? So it's
But you kid.
Yeah.
you could, but that might be too much, right? I feel like you have the right mix.
Yeah, this is very helpful.
I do want people to understand what you're saying when you're actually conveying information.
You could also get a pirate translator on stage with you.
Oh no.
Sorry.
Right, this is
man.
the risky bit. Okay. Cool. Well, thank you everybody. I appreciate all that feedback. That was it actually makes me feel so much more comfortable about doing it in person, like in 2 weeks. I'm really glad.
Just have fun. Just have fun, man. Yeah. I think people will love it. Being silly with great content. I think that'll be great.
Yeah, agreed. Okay, last chance for any questions or more comments or anything. If not, I'm going to ramble for a couple seconds. If you think of anything else, feel free to drop it in the chat. But yes, thank you so much, Mark, for coming on and doing this. I feel like every lunch and learn session you've done here has been really, really great. This one very much included. And yeah, personally, I also love Cypress. So it's really cool hearing any content about Cypress, and especially somebody who works at Cypress has the inside track. So yeah, really appreciate you coming on. Really appreciate everybody that joined us. And feel free to catch us on virtualcoffee.io. We'll have all of our events and everything like that be in Slack and on the site virtualcoffee.io/events. So without anything else, thank you very much, Mark. Thank you, everybody, and we'll catch you next time.
Thanks.
Hey, everybody.